Okay, welcome everyone to this webinar called Beyond Preliminary Design. My name is Juan Zamorano, and I'm product owner at RatedPower, working for the product team. Today I'm with Álvaro Pajares. Please say hi,
Hello,
Álvaro.
hello everyone. Yes, so I'm Álvaro Pajares. I'm also working as a product owner here at RatedPower, where I've been working like for almost the last 6 years, and yeah, happy to be here for this webinar.
Thank you. So this is a very straightforward webinar. It only has two sections and a Q&A section at the end of it. On the first part, I will give you some detailed information about the new grouping algorithm in RatedPower, and then Álvaro will talk to you about the LV groups in Layout Editor. So let's start with it. So this is the new algorithm, this minimize DC. Okay. In a nutshell, its main characteristics are the power station will be always located on roads. All low voltage equipment is distributed inside DC field, and it is focused on saving string cabling. Okay. Next slide, please. Now, I would like to show you what's the big picture here, because now we're delivering this improved MBLV algorithm, but we already have some other strategies in RatedPower, but maybe we're not thinking about this as MBLV strategies. And I'm talking about regular blocks, DC bus, string inverter inside power station, or even this one, this minimize AC, which likely be part of the software in the near future. And these are MBLV strategy because by choosing any of these, we're taking a decision, big decision about main equipment configuration and how it should be placed in the layout. Features like border adaptation, rotation, and so on are more optimization features and are coming right after this MBLV strategy decision. And that's why the MBLV strategy are foundational stones for PV layout. This is what and how you'll see this new feature in the software. In the interface, if you go to the overview tab, you'll see this new low voltage group highlighted here in red on the right image. And within this layer, you'll see each power station with a different color, and this color will be split in several tones. Each tone will be representing a low voltage block. Next slide. Great. And same goes for the for cut files. Okay, there's this new low voltage group on the general layout. And the only difference between the interface and the cut file, it's on the interface, you'll see structures as solid colors just on this layer. And on AutoCAD, a structure will be the same. It means are contour lines with the different colors. Now I would like to show you some detailed information about how this new algorithm works. So think about a central inverter case. The old algorithm works forming the groups from the highest electrical level to the smallest. It means it first creates the power station, then it creates the inverters inside that power station in case of two or more inverters, and it finally creates the low voltage blocks. A new algorithm works in a slightly different way. It also creates the power station on the first stage, but then it jumps and creates the low voltage blocks, and then jumps back and finally creates the inverter inside the power station. And for a string inverter configuration, there's no difference between the new and old algorithm. Now let's talk about the medium voltage part. Here it's an old versus new example, okay, with the same project, different result. And you can see on the right side in the new, it has more regular square shape for each power station, okay, instead of the old version with more unregular eccentric shapes like the ones highlighted with red, blue, or even yellow. And here's another example. In the old version, you can see this very annoying fishbone effect, which is now completely gone in the new algorithm. But why having this regular shape for power station? It's something important. Why is this a thing for our result for our project? Well, the answer is simple. Unregular shapes requires more cabling. Okay, and this is just some random example. In both pictures, we have the same structure and the same amount of structure per power station, but you can see on the right side, the more squarish configuration requires a lot less cabling than the other one. And you can think about it as a geometrical problem. Both versions are covering the same area, but the left version has a larger perimeter. And larger perimeter, it's leading to longer cabling and so on. So this is the problem of bad grouping. We'll pay it with more cabling and trenching. And so how do we get this more regular compact shaped power station? Well, we set some different goal for the algorithm. The old version was very focused on creating symmetric groups, but many times the power station for this group was off center. This configuration. Now the new algorithm is not focused on symmetry. It very allows the asymmetry group, but it is focused on getting the power station at the center of any group configuration. So for any given structure layout, the power station will be always created as priority one by taking a structure or filling position between these grouping axes. Grouping axes are these vertical lines highlighted in red, which are placed right in the middle of two roads. Okay, and by doing this, we can ensure a better quality. Of course, it is not always true for on every single case. The algorithm will fill and will take position beyond this grouping axis, but it is it will always be a priority two for the algorithm. And we've also improved some other problems regarding the grouping. Okay, like regarding the road crossing. So in general, you can expect having 50% less road crossing than the old version. You can also expect less power station divided. Power station divided, it's a PS split in two or more areas, like on the examples here highlighted in magenta. Same goes for eccentric power station. Eccentric power station are PSs completely away from the structure. You will see less cases of this uh, in the algorithm. And we've improved and now this is completely gone, this C-shaped effect for power station, and this problem was linked with the symmetry goal for the old algorithm I told you on the previous slide. And you can see on this old versus new how the new version, this C-shaped effect, it's completely gone. Now that's it on my side. Your turn, Álvaro.
Thank you so much, Juan Carlos. Okay, so from my side, like now we are going to go to layout editor and see what's new. What can we do with the low voltage and medium voltage groups in Layout Editor. Here we recently launched new options to be able to edit low voltage groups and low voltage equipment inside Layout Editor in a manual or a more flexible way, let's say, so that we can ensure that the final design aligns completely with our requirements. As Juan Carlos said, like we have a strategy currently in the software, and in the future we would like to incorporate even more and more. But even with that, if a user wants to edit, slightly change some groups or make some small changes, now they can do it by using Layout Editor and doing those changes. Here we have incorporated options for editing these LV groups in a more manual way, trying to do this as automated as possible, giving options for aligning to reference points, moving some specific meters or things like that. But also we have incorporated an option for doing these LV groups in an automated way, so that users will define the medium voltage groups and where elements are being positioned, and we will automatically get the low voltage groups and the position of LV equipment in an automatic way. We have also incorporated uh, options for accessing inverter level or box level results, including the DC-AC radio and DC power of stream boxes and inverters inside the map, so that while we are editing, we have information about them in real time. Like while editing, we can see how loaded inverters or boxes are. And also, we took advantage of this new feature, and we are also incorporating new UX improvements, where we have added the contextual menu to perform these actions in a smoother way. Also, layers to be able to block or hide any element of the PV layout. Different views, so that we say if we want to see the medium voltage or low voltage represented in the software, and also some changes in the validations tab, so that we distinct in a better way the mechanical and electrical validations. Um, Apart from this, we are always able to launch, or we could launch a 3D energy simulation from these simulations that we have edited in Layout Editor, so that we can get a detailed analysis in case that we want, getting information in 3D, which can be super valuable to define these MV or LV groups. We'll see that now in a moment in the software. Before, just a couple of pictures of what we will see now in the software. In the left, we have an example of how the low voltage groups are represented in Layout Editor. It's quite similar to what Juan Carlos said about the overview. So we have different subcolors for each power station, which each of them represent a low voltage group, and we can see also where inverters are located and the DC-AC radius of all the string inverters in this case. At the right, we have an example with of the automate option, where we can auto arrange the low voltage groups automatically. So in this case, we have incorporated some structures to one power station, but we haven't connected them in low voltage. So what we can do is use the automate option, and the software will do that relations for us. So we will get all the low voltage groups updated, following the idea that Juan Carlos commented, and also inverters placed in the map, so that this addition of LV groups can be also automated in a way. So now I would like to go to the software, and we can see some examples of what options do we have now in Layout Editor to perform these editions. I'm going to go to this example. Here we can see what Juan Carlos said. We have like all these power stations with the idea that he mentioned, trying to minimize the string cables and having power stations as squared as possible. And now we will see that in layout editor we have different views, as I mentioned, for low voltage AC, which will be the central inverter in this case, where we have just one inverter per power station, so nothing changes there. And also the low voltage DC, where we can see the low voltage groups represented in different colors. Also in layers, we can enable the DC power and the DC AC ratio of power stations in this case. We can enable or disable them. And now I would like to go through the options that we have now with this new feature. So if I select one structure, for example, this one, and I want to, let me enable this one, and I want to connect this structure to this box instead of to this one, which is the one where it's connected, we can do it by editing its LV group, and automatically it will change the box to which the structure is connected. So basically this gives us like a lot of flexibility when defining how strings are going to be connected to boxes or string inverters. Also, we could do that by editing the medium voltage group. If I do the same, we will see how the structure is in gray because it hasn't been connected to any box, but we just said that I want to have it connected to the power station. We have kept this option in order to give also the possibility of first defining the medium voltage groups, doing the automate in order to get all the low voltage groups defined, and then maybe make these small additions in a more manual way in case that we wanted to. Then as we see, we have all the boxes here, and if we select them, we can see what options do we have for the stream boxes. We could edit the low voltage AC group. So if I do that, I could connect it to a different power station or inverter. I define the color, and the entire box will be connected to the other power station. While doing this, of course, we can see how the DC-AC ratio of the power stations are changing, like instantly. Then we have also options for moving the stream boxes. When we do this, we can use reference points. So I say that I want to move it to this corner of the structure, for example. This is really useful when we want to align them to a specific corner, and then maybe, for example, here, if I want to move it 1 meter away from the structure, I just define the distance, and the box is moved according to what I have said. The same for the pitch distance. I could move it in the pitch direction. And also we have options for adding new stream boxes, deleting them. If I want to delete this one, for example, I could decide if I want to delete the connected elements or not. And doing so will delete all the structures. But I could also add new boxes. So in case let's select these 4 structures, for example, I want to add a stream box. I could do it from here. And after placing the stream box, for example, here, I will define the color of the box, and the new box is added appropriately. Here, what else you will find in the tool, which is new. Also in results, we now have the connection tree with all the elements that are being listed in the plant. So we now have all the stream boxes here. Let's go to this power station, and let's say that I want to see which box is this one which has less strings. I could go here and say, okay, it's like this one, and maybe now I will add this structure to this box in order to add one more structure and change a bit the DC size of the box. We can do that. And yeah, here, once we are done, as always, we can generate the design, and all the documentation, cables, and so on will be aligned to the changes that we did, and so we will get like all the documentation much more aligned maybe to what we wanted. This is also I did like an evaluation here that I would like to mention, which I think that it's quite interesting. Here, let's say that I had this design where I had only 10 inverters in this case, and we have inverters with different DC-AC radios, 1.277 and also 1.135. Here we have like a specific distribution. In this case, I did it like by columns, let's say, like or by rows, like here 2 inverters, here 5 more, and here 3 more inverters. And now we also with the 3D energy calculation, what we can see is that we have, it was this one, well, it's already open here. We can go to the results of 3D energy, and we can see from the clipped DC energy how loaded these inverters were. Of course, the ones with a higher radio will get more losses, and the ones with lower radio will have less losses. For example, here, this one had around 32, while this one has almost 0. And it's really interesting what we can do now with layout data and editing the low voltage groups, because even here, like for complex terrains or a bit hilly terrains, we can see how this will heavily influence the energy. Well, heavily, it will have an influence, of course, on the energy production. So, for example, we had these 3 examples. This is the same as before, but I edited a little bit the low voltage groups, and we can see how the results are absolutely different. Like the inverter which was placed here has much less energy lost due to clipping, while some others will have more, but we can adapt better, like say maybe the structures that are facing south could be connected to an inverter with a lower DC-AC radio, or the ones facing north to an inverter with a higher DC-AC radio. And we can evaluate that with 3D energy, see what option is better for our design, and that will have an influence on the resulting energy production. So in this case, for example, I did also another evaluation having inverters like defined in a more vertical way. In these 3 examples, of course, we have always 10 inverters with the same radio, but we can see how the energy production is different depending on the case. In this case, we have 5,391. In this case, 5,400, and in this case, 5,398. So we could continue like iterating, having these 3D energy results in order to optimize the energy production. And also, in order to see like the different results or evaluating different options, another thing that we could do is place like do these 2 different configurations that Juan Carlos was mentioning before, trying to place boxes in the as center as possible, respect to their groups, or also place them maybe close to the roads and see what's the difference. I did that for this specific case, where what I did was to take the boxes. We can see them here. We can see how all boxes are placed close to the road, and we have defined the low voltage groups according to that. And we could evaluate these different configurations, get the results with our financial analysis, listing of cables, bill of quantities, and so on, and see what configuration is better for our cases. and we can do that with as what I mentioned, like also for the energy calculation. With that in mind, I did like this comparison for that design that I mentioned, and we could easily see that for the design where I decided to try to minimize the string cables, I got a specific amount uh, of length of cables, and if I did the same for trying to minimize the cables that go from string boxes to the inverters, we can see how the string cables will increase in a heavy way, like will be like more than double the value that we had before, and also how we had like 63% of cables with a section of 6 square millimeters, and now we have only 16%. So we, of course, we are, that's not the objective. So we are like getting longer and with higher cross-section cables for string cables, but we are minimizing a lot the amount of low voltage DC cables. So with this evaluation, we can maybe see what option fits better like our needs and make a decision in order to continue with the project. So now before going to the Q&A section, we wanted to add a poll in order to see what strategy do you normally use when designing PV plants, and see if you prefer like trying to minimize the string cables or minimize AC, or cables that go from boxes to inverters. So here you have the poll. Leave some seconds to answer. Also feel free to, while leaving this time to answer this poll. After this, we'll go to the Q&A section. So feel free to leave any questions that you have in the Q&A section, and we will go through that shortly. I see that we have like so far more people like using the minimize DC strategy, which is great because it's the one that we do currently automatically in the software. And yes, some others that also use the minimize AC configuration, which hopefully soon it will be also an option in the software. Okay, so yeah, thank you for answering. Like 55% of the people will use like minimize DC. So yeah, that's great because you can use it currently in the software. And okay, so thank you very much for listening to the to the webinar. Now we will leave like some time for Q&A, so you can so we can go through the questions. I see there's one question which was if is it possible to place inverters close to the road so that trenches are located parallel to it to the road. Yes, it is like it will be what I have done in this example. Currently, it will be like done in with layout editor, and surely like soon we expect to have that also for with the minimize AC strategy to do something close to that. But here in this example, like where I placed all the boxes in close to the road, if I go to the cables, we will see how here, let's open only the low voltage cables. We will see how trenches go parallel to roads according to the position where I have defined the boxes. So let's see if there are other questions here.
Yes, we have another question, and it goes, in real project condition, what is usually the biggest source of design uncertainty, electrical grouping, cable routing, or energy modeling? And how does your platform help quantify and reduce that uncertainty early in the engineering process? Well, this is a very, very interesting question. And on the side of energy modeling, well, now our software has this very powerful tool, the 3D energy calculation. And from there, you can get a lot of detailed information of your project on an early stage, and of course iterate and see what result can we get in different scenarios. Okay, regarding the electrical grouping or cable routing, well, now this the our current MBLB strategy, it's very tied to the layout configuration. So the cases you can iterate here are more linked with what type of road are you enabling, the number of structure between roads, and so on. And from there, you can only get an automatic calculation regarding cable routing. Okay. In the future, we will add at some point, of course, the edit cabling in layout editor, but as I said, it will be in the future.
Thank you, Juan Carlos. I see there's also another question which is maybe more related to the layout editor, which is asking if is there a faster way to move multiple or all string inverters or boxes parallel to roads across the site. Yes, there is, like let's go to, I don't know, this one. We can select like multiple boxes at once, or inverters, or always in the software, but also let's say let's select that one. And also, well, first of all, we can to select all inverters. If we block other layers, it can be easier, like we can directly select all of them. Okay, we have the 10 inverters, and now we have also the option to manage multiple elements at the same time. So if I select this structure, in this case, it's not like the road is not here, but if we imagine that here there were roads and the road will be here, by doing the align uniformly, if I select this point, we will see how all boxes will be automatically aligned with that structure. So we will have, if the road was here, we will have all inverters close to the road. And now I could, for example, give it like 1 more meter, and that way we will have like all the inverters aligned, and will be done like in a faster way. That will be like the way of doing this action in a fast way. Of course, we will need to align the low voltage groups with the inverters if we do that action, but that we will like align all of these inverters in a fast way. I think that so far these were all the questions that we had. I see that there were also some that we answered like in the chat that were related to whether we will share the presentation and the webinar. You will get like an email with all these sources like of the recording and also some other sources soon. So there you will be able to access like to all of this information. And yeah, also if you have any additional questions about the topic or would like to know more about any of these things that we presented today, we have here our emails, also our customer success team that is always there for helping you with the software. So in case you have any other questions after the webinar, feel free to send them to us. And with that, I think that we can close it here, as there are no more questions. Thank you so much for attending, and yeah, see you soon.